This is our book that we started reading the other day. It is called, let me try to get that glare out, How Big is Big, How Far is Far by Carolyn Janes and John Erickson. Same, How Big is Big, How Far is Far. Page 3. All right. I'll move it so you can see it better too when the glare's there. How big is big? Everyone knows wells are big. A beluga well is longer than a car and weighs about 1,000 kilograms, more than 2,000 pounds. That's big, or is it? So let's kind of see. We can see the beluga well. They're so big. Look at a blue whale, which is the biggest animal that has ever lived on Earth. If you lined up 6 cars, they would be about as long as a blue whale. A blue whale can weigh up to 200 times more than a beluga whale. What's big? It depends. A beluga whale is big, but it would take about 5 of them lined up to be as long as a blue whale. Whether you can call something big depends on what you're comparing it to. It's the same in space. Page 5. For example, think about how big the moon is. It's hard to tell what size the moon is when you look at it in the sky, but if you went to the moon and stood on the surface, it would seem huge. A walk around moon would be more than 10,000 kilometers. That's about 6,000 miles long, which is about the distance from New York to California and back. The astronauts who visit the moon needed this rover to help them travel to the place they wanted to study because it was too far to walk. So the rover is that little guy right there. Okay. Page 6. At the same time, the moon is small, much smaller than Earth. In fact, you would need to line up 4 moons side by side to be about as wide as Earth. So the moon is much smaller. So you would have to take the moon and line them up like 4 of them next to each other, like on both sides, boop, boop, to get the same width as Earth. So width would be like with the biggest part right in the middle. Page 7. Imagine 2 kids are arguing about the size of Earth. The one kid says Earth is big while the other says Earth is small. Who's right? Is Earth big or small? Actually, they are both right because it depends on what you're comparing Earth to. Earth is huge compared to a blue whale, a house, a city, or even a country. There are about 200 different countries on Earth. There are thousands of cities on Earth. It would take more than 1 million blue whales lined up to stretch around Earth. Look at the data on the table. Look at the data table on this page to see the sizes of the planets in our Earth solar system. If you compare Earth to other planets in our solar system, it doesn't seem so big anymore. Is Earth a small planet or a big one? Which planet makes Earth look big and which one makes Earth look small? So you can compare it by this data here. Get it out of that glare. Zoom it in. Okay. So you can compare Earth to the other one. So which one would make it small, which one would make it big, looking at the data. We also can compare them by sides down here. So the pictures, this picture shows the sizes of the planets. Ooh, there's a nasty glare on there. Hope you can see that okay. Let's see if we can block it out. Nope. So we have Jupiter, Saturn, Uranus, and Neptune. Okay, so you can kind of compare them by that too. Jupiter is the biggest planet. Sorry guys. Jupiter is the biggest planet in our solar system, and its diameter is about 11 times bigger than Earth's. That means if you lined up 11 Earth-sized planets side by side, they would be as wide as Jupiter. Jupiter really is big, right? It might seem that way, but there's something in our solar system that makes Jupiter look small. So let's see. So that's how kind of the moon. So there would only be 4 moons to go across the Earth, but there's 15 that go across Jupiter. What is it? That's right. It's the sun. The sun is so big that it makes Jupiter look small, and it makes Earth look tiny. In fact, the sun's diameter is almost 10 times the diameter of Jupiter and about 110 times the diameter of Earth. The sun is the biggest object in our solar system, but our solar system is only a small part of the universe. Is there anything out there that would make the sun look small? When you look out into the night sky, you may see many stars. They look tiny. They look like tiny specks of light, but are they really tiny? That's page 11. Page 12. Arcturus is one of the brightest stars you can see in the sky on a summer night. If you lined up 25 stars the size of the sun, they would be about as wide as Arcturus, which means Arcturus is definitely big. By now, you probably know that there's always something bigger out there. On winter nights, you can see a bright star called Betelgeuse, which would have to line up 40 stars the size of Arcturus, or 1,000 stars the size of the sun, to be as wide as Betelgeuse. Is the sun big? As the only star in our solar system, it seems big, but when you find out how big some other stars are, the sun doesn't seem so big anymore. Let's look at some data on different star diameters. So that's our sun, and that's Arcturus. And then here is those other ones they were talking about. So here's our sun, Arcturus, and that Betelgeuse or Betelgeuse. I like to say Betelgeuse like the movie. An artist created this image showing what the huge star Betelgeuse might look, or Betelgeuse, I think it's Betelgeuse, might look like if you got close to it. If the sun were next to Betelgeuse, it would look like a tiny speck. So probably like one of these other stars, right? Page 14. We've discovered that things in space are very big. Things in space are also very far apart. But how far is far? Who lives close to school and who lives far away? In places where people's homes are close together, many students live close to school, sometimes just a block or two away. In these places, people might say students live far from school if they have to walk more than half an hour to get there. In places where people's homes are farther apart, some students may have to have a long ride in a car or a bus to get to school. And a half-hour walk to school would not seem far at all. Do you live close to your school or far away? That depends on what you're comparing the distance to. It's the same in space. Page 15. If your car could drive from Earth to Sun, it would take more than 160 years without ever stopping to get there. Are we there yet? Distance. Distance in space depends on what you're comparing. Earth is about 150 million kilometers, that's 93 million miles away from the sun. That's far. It makes sense to say Earth is far away from the sun. Or does it? Page 16. The diagram on this page is made to help you compare the distances between planets and the sun. It does not show the sizes of the sun and the planets correctly. If it did, then the planets would be too small to see on the page. So here we go. Here's the sun. We have 1, 2, 3, 4 that are pretty close to it. Jupiter, Saturn, Uranus, and then Neptune's all the way out here on the other page, which I could kind of show you without the glare. So page 17. As many have guessed, you can say Earth is still close to the sun. You can say Earth is far from the sun. Either way, you're right. Compared to some of the other planets, Earth is very close to the sun. The farthest planet is more than 4 billion kilometers away from the sun. That's only one distance. That's one distance we can definitely say is far, can't we? So look at the data here. So we have all the planets and their distance from the sun. These are approximate, so they said right on, they're about that far. Page 18. Is the sun near Earth or far away? From our perspective, the sun is far from Earth, but is extremely close for a star. Compared to the sun, the other stars are much farther away. Besides the sun, the next closest star is called Proxima Centauri. Centauri? It would be a very long ride to get to Proxima Centauri, even the fastest spacecraft that exists. The fastest spacecraft that has ever launched travels about 50,000 kilometers or 31,000 miles every hour. Even at that speed, it would take almost 90,000 years to get to Proxima Centauri. The fastest spacecraft ever launched is called New Horizons. It does not carry people. So there it is. There is something that travels much faster than any spacecraft, light. In a year, light travels about 10 trillion kilometers, 6 trillion miles. That is the distance astronomers call a light year. A light year is not a long time. It is a huge distance. It takes 4 years for light to travel from Proxima Centauri to Earth. So we can say that Proxima Centauri is 4 light years away. A light year is such a long distance that the distance from Earth to the Sun is only a tiny fraction of a light year. Here's a data table showing the distance from Earth to a few different stars. So let's look at, here's kind of an illustration of it for 4 light years. So light years take 4 years to travel this far. So Earth, or from here to here, it would take 4 years. And that's just for light. All right, so here we go. We're gonna have to convert these into fractions so we can see. So here's our data here. And then we'll have to do some fractions so we can kind of see what those look like. It's hard to visualize how far away stars are. A long time ago, people thought that all stars were the same distance from Earth. They thought the stars were attached to an enormous sphere that surrounded Earth like a giant shell, and that the stars on the sphere surrounded Earth in all directions. They thought the stars were stuck to the sphere and never changed their position on the sphere. This diagram shows, shows the way people once visualized the stars. People used to imagine that all the stars were the same distance from the Earth. So that it was just like kind of a sphere, like it would go around the Earth and just like a ball, almost like a ball of just different stars. Page 21. People were right that the stars were all around the Earth in every direction. You can imagine why they thought that the stars were stuck to something. After all, we always see the stars in the same arrangement in the sky. However, there's no shell around Earth, and stars are not all the same distance from Earth. Even stars that look close to each other can be different distances from Earth. For example, the 3 stars that people call Orion's belt look like they are lined up side by side. But if you saw them from somewhere else in space, you would see that they're spread far apart. And each of their 3 stars is a different distance from Earth. So here's Orion's belt. And so we can see they kind of line up, right, in a row. But if we look down here, so before, if they were all lined up like how we see them, we would think that they would go straight across this way. But they are all different. They're all farther apart from Earth, okay? So that means that they are, like this one's probably burns brighter than this one does, because if we can see it the same that far away, then then it's gonna be, that means that must have to be brighter than like that one. Page 22. In this book, you have seen a diagram representing distances in our solar system. You can use the diagram on page 16 and 17 to compare how far Earth and other planets are from the sun. You have also seen a diagram representing distances beyond the solar system. You can use the diagram on page 19 to visualize the distance between Earth and the nearest stars besides the sun. It might seem like a good idea to end this book with a diagram comparing distances inside our solar system and beyond the solar system at the same time, but there's a problem with trying to do that. The distance between Earth and the sun is 150 kilometers. If we make a diagram that represents the distance as 1 centimeter, how far away on the page do we have to put a picture of Proxima Centauri? We would have to put Proxima Centauri 2.7 kilometers away, about 1.5 miles. Proxima Centauri is about 270,000 times farther away than Earth than the sun is. There's no way to fit a diagram comparing those distances in any book that has ever existed. The diagram and the book would have to be much too big. Are the Earth and the sun close together? Is Earth small? Are the stars far away? Is there anything even farther than stars? Big or small, close together or far apart, whichever way you think about it, it makes sense. And then we have our glossary, and that is it.